Hello and welcome to this video on dividing polynomials. We talked about polynomials, how to add, subtract, multiply, and now we're going to divide using an old trusty method we've learned before, long division. Let's get started. So here's a simple problem that you could divide. Remember, fractions are just division problems where you would divide 525 by 25. Now, normally what you would do in the past is some of you would set it up like this and apply that long division where we take, the 25, we figure out, oh, how many times can 25 go into 52? Twice. And then you do 2 times the 25 and gives you 50. You put that button beneath it. And then you subtract and then start the process over. 25 goes into 25 one time. 1 times 25 is 25. There's no remainder. Your answer is 21. When doing with polynomials, you actually end up doing the same thing. You have to do this whole process where you look at a certain part of the problem and you figure out how many times does that number on the outside go into it, and then you go back and multiply, write it underneath, subtract, and then start over. All right, it's those steps over and over. You look at the numbers, try to figure out how many times it goes into it, and then you multiply, subtract. All right, it's kind of like divide, multiply, subtract, over and over. All right, same process. Here's an example you might see. Okay, now before we get to long division, some of these problems can actually be solved like normal. All right, so instead of long division, sometimes if you have just a monomial on the bottom, you can actually use the simplifying radicals and just separate it out into its parts and just cancel and reduce as needed. So for example, if I take this 12x to the 5th and I'm going to separate each part because I'm dividing each term, because I'm dividing everything by 3x squared, it's actually okay to write it like this, or you're dividing each and every part, each and every term that's separated by 3x squared. And you notice this actually makes it a little easier because you can reduce the fractions, like 12 and 3 gives us 4, x to the 5th and x squared. Remember, exponents, when you're dividing, you subtract them, so 5 minus 2 is to the 3rd. 6 and 3 gives us 2, 2, and x to the 4 minus 2 gives us x squared. And negative 9 over 3, that is just 3. And x to the 3rd, and x squared, 3 minus 2 is just x. And then you have your answer. So sometimes it can be simple if you have a single term, a monomial on the bottom. There's only one term, okay? But if there's more than one, like x plus 7, you actually have to apply that long division. And this is kind of how it works, okay? When you apply the long division, you're going to put the top part here, the numerator, on the bottom. That's what you're dividing with. And then you're going to put the bottom here on the outside. All right, so once you set this up, we're going to apply those steps where I look at a certain part of it and figure out how many times one can go into the other. And then I'm going to multiply that out, write it underneath, subtract, and then start the process over. Bring it down, start the process over, okay? So to solve these, I'm going to start by only looking at the first terms. Because just like we did earlier when we had the 25 divided by 525, you look at the first parts of the equation. Okay, you look at the first part of the problem. So here, we're going to do the same thing where we're only looking at the x and the x squared. Okay, how many times does the x go into the x squared? Now, if you really think about it, you can go to the side and divide these x squared and x. If you divide them out, there's going to be an x left over. So at the top, we're going to write x. Okay? And then what we end up doing, the next step is multiplying back. X times x gives us x squared. All right, but don't forget you got to multiply to everything. So we're going to multiply x and the 7. So x times 7 gives us 7x. All right, and then that last step you kind of notice is that we need to subtract. So I'm going to subtract everything, and I like to put this in parentheses to remember that you're subtracting, because x squared minus x squared cancels, but 9x minus 7x. Notice it's 9x, not 9x plus 7x. A lot of people look at just this part and think you're adding, but you're actually doing 9x minus 7x. Okay, so 9x minus 7x gives us 2x. All right, and then you start the process over. So I'm going to bring down the 14 and then start over, okay? Look at the first parts of the equation, so the 2x and the x, and divide them, figure out how many times it goes into it. Well, 2x goes into x, there's going to be a 2 left over, so it's going to be twice. So you're going to write 2 here. It's a positive 2, so write plus 2. And then you multiply it out. So the 2 times the x gives us 2x. 2 times the 7 gives us 14. And you notice 2x plus 14. Oh, great. If I subtract these, they're all going to cancel. 2x cancels 2x, 14 cancels 14. There is no remainder, so our answer is going to be what we have at the top here, or x plus 2. Okay, it's just like that. All right, I'll do one more example. When you're dealing with a problem like this, sometimes you'll notice that it is not balanced. You're going to have to put in what's called these placeholders, or the missing terms, to actually be able to divide, like with long division. So what I mean here is that when you're dividing long division, you have to make sure there's some number, let's say it's a, with like an x, let's say to the 5th, if that's what you start with. Then there should be some number with an x to the 4th. There should be like a number x to the 3rd, and then a number with x to the squared, all the way until they're in order. So notice how you have to have x to the 5th. That means you need to have to the 4th, to the 3rd, and the 2nd power. So notice here we have to the 3rd power, but you need and then it goes to the 1. You're missing a square here. You're missing the 2nd power somewhere. So what we're going to do is write this little placeholder, I'm going to erase this, that shows that you can still divide this, but you're going to put a 0 in the number instead, because it's not really there, but it's a missing 0. It's just a placeholder. So what I'm going to do here is when I write my long division, you have 2x to the 3rd, but I'm going to place this missing term, which is going to be just the 0x squared, because that's what's missing. Then you can write the rest of the problem. Excuse me. So negative 6x and 15, and then I want to divide that. So now I have this set up, and including the placeholder, you notice it's 3, 2, 1, so we're okay. We don't have any missing terms, and then start the process over. All right, so look at the first two parts. So I'm looking at just the 2x squared and the x. I'm going to divide those, and you notice that 2x cubed divided by x gives us a 2 with an x squared. So I'll write 2x squared up here. Go back and multiply. 2x squared times x gives us 2x squared. 2x times the 1 here is going to give us just 2x squared. And then I like to put it in parentheses to remind ourselves that I'm subtracting. So 2x cubed minus 2x cubed, that should be cubed, would cancel each other out. But then 0 minus 2x. So a lot of people, when they look at this, it looks like 0 plus 2. Oh, that's just going to be 2x squared. However, it's 0 minus 2x. And 0 minus 2 is actually going to be negative 2x squared. So that's why I like to write those parentheses, okay? All right, and then bring down the next term and start over. Focus on just the first part, the x and the negative 2x. Divide that out. So negative 2x squared divided by x would give us negative 2 with an x. Okay, and then I'm going to write that up here. And then go back and multiply both of those. Okay, so negative 2x times x is negative 2x squared. Negative 2 times 1 gives us negative 2x. Put our little parentheses to show that I'm subtracting. Negative 2 minus negative 2 and just cancels, because when you subtract the same things, they go away. But then negative 6 minus negative 2. Notice how it's a minus a negative 2. Minus a negative 2 means you're actually adding to the negative 6. So negative 6 minus negative 2. So the opposite of minus is I'm going to be adding. So negative 6 plus 2 ends up giving us negative 4x. Bring down that last term and start over. All right, so go back, do the process again. Focus on just the first part, so the x and the negative 4x. So negative 4x divided by x leaves us with negative 4. Put that at the end. Go back and multiply that negative 4 to each of these. So negative 4 times x is negative 4x. And then negative 4 times 1 gives us negative 4. Put our parentheses and subtract. Negative 4 and negative 4, they cancel because they're the same. But 15 minus negative 4, minus a negative means I'm adding 4. So 15 plus 4 is 19. So this problem's a little bit different because we have a remainder of 19. All right, so when you write your answer, so this is my final answer here. When you write your answer actually becomes 2x squared minus 2x minus 4, but then your remainder is written on top of what's written as your denominator. So 19 over x plus 1, and then that's your final answer. Because you couldn't fully divide this 19 part, so it's still being divided by x plus 1. It's a little remainder, so you kind of have to write that at the end as well. Okay, that's dividing polynomials. All right, it's a bit of a process. It's a process that's repeated over and over, but it's a process that we kind of know already, long division. All right, I'll see you guys in class.